It's time for another math easy solution. We're going to discuss, well, basically the limit laws and go over a brief overview of this. These are basically laws or properties of limits that you could use in solving limits instead of having to use a calculator or do graphically, etc. And I'll find the proof for all of these in later videos. I'll do examples and proofs in later videos. They're a bit more complex, the proofs, but basically they are pretty straightforward just in understanding why these proofs or these laws should be true. So let's just go basically with the limit laws. Suppose that the constant, this is C is a constant and the limits below exist. Basically limit as x approaches a of f of x and of g of x here. So if these limits exist, assuming they exist, then we have the law 1. It's also called the sum law. Basically if you have a limit as x approaches a of f of x plus g of x, then this just equals to the limit x approaches a of f of x plus the limit as x to the a of g of x. And this is called the sum law because the limit of a sum, basically it states that the limit of a sum is the sum of the limits here. As you can see, there's a sum in here. Now this is basically limit of, basically a sum now of these limits. Now we're basically adding these separately. And then law 2 basically states this is limit as x approaches a of f of x minus g of x. So now it's a difference here, you're subtracting, and then you're just going to have limit the same exact as above, but you switch the plus and minus signs. So you have something like this here, and this is also called the difference law. And this basically you could state it as such that the limit of a difference is the difference of limits here. So as you can see, there's a limit, there's one limit of a difference, and then it's just going to be the difference of these two limits together. And then also law 3 now, if we go, this is also called the constant multiple law. If you have this constant in front, then basically the limit of this c times f of x, you could just take out that constant out of there because it won't affect the limit. Then you're just going to have limit x to the a. And you could also verbally state the law as the limit of a constant times a function is the constant times the limit of the function here. So just kind of take it out and you're just doing multiplying it by the limit without it in there. And then law 4, basically this one is the product law. Basically when you have the limit as x approaches a of f of x times g of x, then this is also equal to the limit as x approaches a of f of x times the limit as x approaches a of g of x here. And then you could also state it as limit of a product is the product of limits, exactly as stated, similar to the above laws here. In law 5, the last law is the quotient law, similar to the ones above, but now you're going to have divide by 0 statement here. So basically limit as x approaches a of f of x divided by g of x, this just equals to the basically the limit as x approaches a of f of x divided by the limit as x approaches a of g of x. This is only if the limit of a of g of x approaches a is not 0, because you can't divide by 0. And this is a quotient law, and you could basically state it similar to above. The limit of a quotient is the quotient of the limits, provided that the limit of the denominator is not 0 here. Yeah, and basically it is easy to see why these properties are true. For example, let's say the limit, or let's say f of x. Now we could just say, let's say f of x is close to, let's say the value L is close. Yeah, and basically the value g of x is just, let's say it's close to m. Then basically the addition of these two plus f of x plus g of x, let's say this is going to be equal to, well, let's just write close to, we don't need to write equal, close to L plus m. So that's the law 1 state, the sum law. Basically, this is kind of, you kind of have this kind of idea here. Basically, if you have these separately, you know it's close to L, this is close to M, then you're just going to do the summation separately. It should be equal to the same thing if you do the limit of both these together. And basically in my later videos I will basically have examples and precise proofs for all of these laws, and also when to use them in the examples, which would be pretty useful. Well, that's all for today. Hopefully you learned about these laws. Make sure you remember them. They're pretty straightforward. Every time you see a limit like this, you know that you could just break it apart, do limits of both, etc. Remember, you could also download the notes, these notes in the Dropbox link below, and yeah, stay tuned for another math easy solution.